Okay, started. Can you see my screen?
Yes.
Last time we discussed about data modeling, so we'll continue from there. So as we discussed, like when we are talking about data modeling, basically these are the three basic data modeling approach: ER data modeling, dimensional modeling, and data vault modeling. So when it comes to data, these are the three model. But earlier there was one more model which was like object data model. It did not succeed. So means around 2000, it was means pushed very hard by Oracle and other companies. But after 10 years, they simply discarded. So they found that, okay, object data model does not work for data, basically database related. So those has been discarded, so we don't discuss. But object data model, as we know that it works when it comes to application, like especially Java and Java type of application. There we define the classes and all those inheritance, everything. So there in application it works, but related to data, business data, it is not successful. So that data model we don't discuss. So these are the three model: ER model, dimensional model, and data vault model. And as last time we discussed, ER model is the best suited for transactional database. Dimensional model is the best suited for analytics and reporting purpose. And data vault basically fits in between. So nowadays, as we are talking about data lake, data lake basically is you can say like it is historical transactional data. That means whatever transactional data you have in OLTP system, generally it is kept for a very short period, like maximum they keep for 1 year. Some companies they keep for more years, but it is a waste of basically time and waste of resources. Because in OLTP system, when you keep the data very high volume for very long period, it impacts the performance. And for OLTP system, performance is the first criteria. That is why it is the best practice to keep OLTP data for very short duration so that the size of the database is reduced. So if the size of database is reduced, resources consumption will be less. But the best thing is you get the best performance for your application. So that is why in the transactional database, we don't keep data for very long period. Generally, they keep for maybe, it depends upon the business. So if suppose business is generating very huge volume of data on daily basis, then you may find that, okay, they might keep just 1 week or 2 weeks data. And every week or every 2 weeks, they take the backup and remove it. Like in case of, you say, take example of retail business. So in retail business, whatever bills are generated, generally life of those bills or those bill items may be 1 week or 2 weeks. So what they do is once it is 2 weeks are over, they take the backup of data in other system, either offline backup or online backup, and they remove from their main OLTP database. So it depends. But suppose if you're talking about home appliances where they have to keep the data as per the warranty period, like 1 year or 2 year or 3 years. So they keep those data in their OLTP system, but they might keep just the bill details and items. It may not be possible that they will keep each and every transaction details incomplete. So they might keep only whatever data is needed for warranty, and rest of the data they move to other system, which is their backup system. So in a transaction database, we don't have a data for very long period. When it comes to data warehouse, as we know that when it comes to analytics or analysis of data for different patterns and trend, then we require data for multi-years. So it is like in worst case scenario, they will go for 5 years for any outcome of analysis, any good result from analysis, so that they can project for future. So for that, they need at least 5 years, but that is the minimum 5 years data. But the best, it is assumed that, okay, 10 to 20 years data is good enough. So generally what companies they do is they either analyze the 10 years data or 20 years data, but again, it depends upon the domain. Like you see this election is about to come. So during election, you will find that each and every news channel will analyze that who is going to win, who is going to lose, who will get more seat. So for that, they need analysis. So for them, what requires is they need maybe last 5 or 10 election results are data. So that means they require data for last 30, 40 years. When it comes to insurance companies to analyze how the pattern is changing, how the people's options are changing, they might not be enough 5, 10 years data, because if they are going for life insurance, so it is like 25, 30, 40 years data they require. So it depends upon the business. So once you go to a business and you see the business domain, you have to discuss with the business people. Especially business people means not the uh, staff level. You have to discuss with the management level, who are responsible for analyzing the data or forecasting for the future. So those kind of people basically will give you idea that how many years data basically they analyze. So you get idea, okay, 15 years, 20 years, 30 years, 40 years, whatever. So those many years of data you have to keep in data warehouse. So whether volume is small or big, it doesn't matter. If they say, okay, I'm analyzing 20 years data, so data warehouse has to keep 20 years data. So to get the better performance again, to get the performance again in data warehouse, so what we do is we don't keep the data at the transaction level. We try to keep at the summary level, because any kind of analysis for future projection, we have to group the data at the summary level. So summary may be, it may be at the very lowest level of summary. Suppose we have a transaction data, we might go for, okay, let me summarize the data at hourly level, means how the transactions are happening in my supermarket hourly level. So they do this. So if you see in supermarkets, if you go in early morning, you will find the vegetables are costly. When you go in the evening time, same vegetables will be very cheap, maybe half or maybe more than half. So how this is happening is because they are doing analysis at the hourly level. So they know that vegetables are fresh in the morning, more and more people come to buy. So they keep the price a little high. And when they know that, okay, evening time, people rarely come, or very few people will come to purchase vegetables. So they keep it very low. If it is over before evening, then fine. But if it is not over, then whatever is left, they will keep the prices very low. So these are the things which are not done suddenly. It has been after analyzing a lot of years data, they find that why these products are selling in the morning more and not evening or afternoon. So that kind of hourly analysis they do. So mostly in the retail business, they have two kinds of one is a perishable items and other is non-perishable items. So when it
Rahim,
comes,
please.
yeah,
Sorry to butt in. Just admit him, Isfahan, in the meeting.
okay, okay, okay.
Sorry.
Let me. Yeah, it's done. Check with him. He's able to connect.
Okay.
Yeah, Tariq, he is there.
Yeah, he's there. His audio is connecting.
Okay.
Yeah, please start now.
Okay, okay. So in case of data warehouse, we require basically summarized data. So summary may be at the hour level, day level, or week level, or month level, or quarter level. It depends. Basically, different group of analysts will be analyzing the data at the different level. So this is a big challenge. So keeping data in the data warehouse or data mart at the transaction level basically is not possible, first thing, and it is not advisable, because analysis is not done at the day-to-day transaction level. It is always done at the group of data, which is nothing but summary of data. So that is why in the data browse we needed another data model. So they came with dimensional model, because in dimensional model uh, the major consideration was not on the duplicate of data. They said that, okay, you duplicate the data as much as you can, but try to reduce the number of tables, and also try to reduce the number of relations among the tables. So in ER model, you have hierarchy of tables, means table A to B, B to C, C to D, D to E, like that hierarchy will be there. So there will be more links. When you are writing a query, you will have a more joins. But in dimensional model, they made in such way that number of hierarchies can be reduced or is reduced. So they have a star model where hierarchy is only one level, means it is a dimension and the fact table. So it is just a one hierarchy is there. All the dimensions will be directly linked with the fact table. And other approach is which is basically a snowflake model. So in snowflake model, again, it basically is very similar to ER model, where you have a hierarchy of table as a hierarchy of dimension. So there you may find, okay, there are 5-6 tables which are linked as a parent child at the different level. And that is why snowflake model is not very popular, but still it cannot be avoided completely. Somewhere you require hierarchy. So wherever you find that, okay, this hierarchy is non-changeable, it means this hierarchy is static. It will never change in future, or it might rarely change in the future. So those hierarchy we take in the data warehouse in dimensional model. So dimensional model was introduced basically to summarize the data, aggregate the data, and reduce the number of hierarchies among the table. So that became popular with the data which is required for analysis and reporting purpose because performance was improved. But the problem here was, the biggest problem or the biggest challenge was that when we are preparing a data warehouse for any company, and company's OLTP database has only 1 year data, but data warehouse requires 20 years data or 15 years data or 10 years data. So one of the core challenge was, okay, if we are building the data warehouse, we are writing the ETL process or programs, which will fetch the data from OLTP system and dump into data warehouse periodically. It may be like every 4 hours, every 2 hours, or every 1 day, or every week. Data will come from OLTP database to warehouse database. But the challenge was, okay, current year data will be available. What about the previous 19 years data? How to get it? So that was the biggest challenge, because when we say previous 19 years data, earlier it was offline backup. So it was like backup has been taken into tape drive or uh, other storage devices which are available nowadays. So it was like offline backup. So first thing was, you have to make it online. Then only your ETL process can connect to them and access the data. So that means making it online requires another set of your transaction system. You cannot load in the same transaction system because it will impact your current operation. So it was like you need a client need to have another server, same kind of application should be installed there, means database application, whatever. So it was a challenging job. Second most challenging job was when we are talking about 19 years data. So it may be possible that whatever is the table structure today in our OLTP system, same table structure will not be over the period of time in the past. So it is like, maybe if you have a customer table with maybe 60 column today, if you see the structure customer table 3 years back, you'll find, okay, there was only 40 columns. 10 years back, it was only having 30 columns. So over the period of time, table structures are changing. Number of tables are increasing, relations are changing. So that was the biggest challenge. Means when we look back at the 19 years data, we'll find that whatever ETL programs we are writing now for current data structure, it is not the same 5 years back or 10 years back data structure. So it was like we have to again tweak our ETL as per the old data structure, or you write a separate ETL program first to make those data structure which are in the 19 years, make them very equivalent to the current one using some dummy columns and some dummy data, and then only you get it loaded. So it was a very tough to load the data from OLTP system to warehouse system apart from the current data. So how to tackle this challenge? So they came with idea, why not we keep our OLTP data with the old data? So some companies they started like, especially with the ERP, it was there like they used to have a 10 years data, 15 years data in their ERP system. So as I said, like you can keep it, but the problem only will be performance of your OLTP system will be affected very badly. So then companies realize, no, this is not going to work. You cannot just keep having data OLTP system for multi years. So then they said, okay, why not we create OLTP backup online? So it is like whatever database we have, let us create one more server, backup server, and keep this structure there. So it was like just copy structure every year. So this was fine, but the only problem was every 2 or 3 years your structure is changing. So again, the same issue was there. When the structure is changing, how you are going to load the data in data browse from different set of structure of table for the last 10, 15, 20 years. So this problem means this issue again given a means idea that okay, this is not going to work because just copying the structure online instead of offline is not going to help because table structures everything is changing. Then this data vault modeling came into picture. So what they said that let us build one more database between OLTP database and warehouse database. So they said that then idea came, okay, why don't we have a data lake kind of database? Means it is historical transaction database, but with a different data model. It should not be like just a copy and paste or just copy and dump. So then the data vault modeling concept came, and primary purpose of data vault modeling was that make a data structure in such way that whenever any changes are happening in the OLTP database, those changes should be absorbed by the data vault without impacting the existing data structure. So that was the core concept. So core concept was that okay, in suppose your source system means OLTP system, you break your customer table into 3 tables. Now I have a data vault model based database, which is a data lake. Already there is a customer table, but now the customer table has been broken into source system. So is it possible that in the data vault or data lake, you can absorb the table structure changes without affecting the existing table and their relation in the data vault? So that was the core purpose. And that is why in the data vault, whatever structure we define, it is purely based on many-to-many relation. So it means they assume that each and every object in database, or you say entity in real life, they have many-to-many relation. So they say that remove this concept of one-to-one relation or one-to-many relation. Assume that all entities have relation based on many-to-many. And based on that, they define the structure and the relation among the tables. Second fund of what they said that once data comes into data vault or you say data lake, it should never be updated and should never be deleted. If suppose something has been wrong, it is like you loaded some wrong customer data. What they say, okay, let it be there, mark it with some flag, keep some columns as a flag like unwanted data or wrongly loaded data, and load the data once again. So it is like a concept was always growing data, means no update, no delete. You cannot update, you cannot delete. You cannot means we have to follow this rule that we should not define a database in such way that applications are going and delete the data or update the data. So it should be always growing. So main primary purpose of data vault modeling was basically to make transactional data available for the future use without any delay, without any structural impact. So it was suggested that okay, let us go for 3-layer concept. OLTP database. Whenever your OLTP database life expires, it means 1 week or 2 weeks or month, a year, move the data into data lake, which is nothing but transaction level data, but it will hold the data for as many years as you want. And from data lake, you take into your data warehouse. So whether you say data warehouse or you say data mart or you say OLAP database, whatever. So reporting should be based on OLAP database, which is your data warehouse or data mart. Transactions are working against the OLTP database, which is based on ER model. And in between is sitting is your data lake, which is based on data vault model. Because of flexibility it provides to absorb the changes from OLTP system. So this is the concept now is getting the means it is having a you can say good ground, and most of the companies are now going in this approach. It takes time, but the biggest advantage of this approach will be like whatever data is required in future for analysis purpose or for any other purpose, they always get it from the data lake. So data lake is like a very big storage, means you can say like a big data. This big data concept came earlier for that purpose only, but only problem was they have no data model specific. So they said, okay, let us keep the data in file, let the file grow like anything, because with the help of infrastructure, we will be able to get the performance. So it was not very practical. So, and that is why you see after about 10 years, now people are not talking much about the big data. Instead of now, they started talking about the data lake. So when it comes to business data, I'm not talking about business data unstructured. Like when you talk about audio data, video data, or you talk about image picture, those are the data which again is still among these data model storage is a big issue, because keeping those data in a database is a very challenging and it impacts the performance. But when you see the business from business point of view, how much they analyze these kind of data, it is like just 5%. 95% of business analysis still is based on structured data. But when it comes to social media related things, then it is like unstructured data is the more important. So for that, they have a approach, like when we are talking about big data, we are talking about NoSQL. So those kind of things are there for unstructured data, which works very perfectly. But when it comes to structured data, then these are the model where we have to. So mixing this data model, suppose if somebody is trying to keep the data structured and unstructured both using any one single data model, it will fail. So you have to always think in the two way. Okay, what should be my approach for structured data of the business, and what should be my approach for the unstructured data of my business? So unstructured data means, as I said, audio data. And when we say streaming can be for both type of data. It can be for structured as well as unstructured. So we should not think about streaming means audio video. It is not. Streaming can be for structured data also. Nowadays, they are getting the structured data through streaming pipeline. So only thing is where you keep it, in which format you keep it. So that we have to be very clear. Mixing this together with one data model or with one single process is practically not possible. It creates a problem in future. So that is why we have to think in the two different directions. So these are the three data models which we'll be going to discuss. And next is when we are talking about data model. So generally when we prepare we work as a data model, we should prepare some diagram. Nowadays, I see that most of the companies, they don't prepare this diagram, very few. And that is why they struggle. So here basically is the conceptual model, logical model, and physical model. These three type of diagrams we have to prepare. Out of these three, conceptual model you'll find will be very rarely, because conceptual model is related to business. So it is like when you have a business analyst and the business analyst is interacting with the business users to get their requirement, at that time conceptual model is prepared. So basically primary purpose of conceptual model is to draw the diagrams using the entities of the business, how those entities are related. So whether you refer them as entities or relation, or you refer them as a business objects and relation. So basically things which are involved in the business. So those we refer as entities, or we refer them as objects. So if someone is coming from object oriented, he will use the word object. And people who are coming from this modeling approach, they use the word entities, but both are same. So whether it's a business entities or business object. So basically, suppose if you are a business analyst and you need to talk to business people to understand how the customer and sales are related. So they will tell you in a very simple English language, but it is always risky to take the conclusion or decision based on their explanation. It is always a best practice. Draw some diagram and get the diagram back to the users and say that, see, is this the way how the things are related? So suppose if you find that there is a customer and there is a sales, so you draw two boxes, one customer, other sales. And if that fellow says that, okay, one customer might come and he may perform multiple sales, means he may go for multiple purchase. So purchase what is from customer point of view, but from business point of view, it is a sales. And since we are working for the business, so we use the term which is for business, not for the other way, means other party. So one customer may come for multiple sales. So you make the relation between customer and sales and say that, and showing the diagram, you say one customer, multiple sales. But it may be possible that business user forgot to tell you that one sales can be by multiple customer. Or if he says, yeah, it is possible that one sales can be by multiple customers. So as a business analyst, we know that Practically, it is not possible that one sales or one bill will be for multiple customers. Means it is like I go to supermarket and you also go to supermarket, and then I take 4 items, you take 3 items, and for both he generates one bill. So practically, it may be sometimes it is possible like two friends are there, they take one bill only, and after coming out of supermarket, they distribute their items. But from business point of view, they are not two customers. This is only one customer. So if suppose the business says that okay, it is possible that one sales can have a multiple customer, so we have to cross check because practically it doesn't seems to be possible. So from business point of view, it will not be possible because if one of the friend is paying the money and the other friend is just standing there and just looking at, so for business, it doesn't matter that there are two friend or four friend. We will say that only one customer because payment is done by only one person and bill generated is only one. So for such kind of things, we have to prepare a conceptual model. So in conceptual model, generally what we do is we identify the entities and then we identify what are the entities which are related with each other directly and what is the type of relation. So these three things we try to define with the help of conceptual model. Attributes level, we discuss later. Means it is like once these things are done, we say that half of the job is done. And then comes, okay, what should be attributes for customer that we distribute as a business analyst. Then it goes to data modeler. He will apply the data modeling rules and then he will find, okay, some of the business attributes or some of the attributes does not belongs to this entity. It belongs to some other entity as per the relation. So that comes when you start applying the modeling approach. But as a business analyst, you have to prepare a conceptual model. Now, in today's time, scenario comes where a new database is very rarely designed. Mostly what happens, already systems are there, 2, 3 systems are being used by the company for 10, 15, 20 years. And now they are fed up with those problems which are arising from those databases. So they want to integrate them and make a single database. So in that case, what they say that you go and look at those databases and develop our new system with a new database so that we can basically direct our applications to work against this single database and obsolete those previous 3 databases. So in such case, what we do is we know that, okay, we have to basically go through the database system, prepare the diagram. So there we don't prepare the conceptual model, but we prepare the logical model. So whatever tables are available in those or files are available in those systems, we take them, we prepare a diagram as per the database relation. We try to make the relation, means whatever is the existing as it is, we try to prepare. And then if there is a business analyst, we cross check with the business analyst. See, these are things which I got from the database system. Is it the same thing is still happening or there is going to be some change? So it may be possible that these systems are designed 15 years back. At that time, client was very clear that, okay, there will be only one payment from one customer against one bill. But now flexibility is that, okay, one customer can make a payment for multiple bill, and also one bill can be paid by customer multiple times in multiple parts. So earlier it was a one-to-one relation, but now they are going for many-to-many relation. So once we build our logical model, where we basically show the tables and the relation, or instead of table, we can say tables, you treat them as entities and then define the relation. So this logical model preparation is very important, and generally logical model we prepare at 2 levels. Logical model at the entity level and logical model at the attribute level. So entity level basically just to put the name of the entities, or you can say name of the table and the relation, that's all. So that is the first stage where basically you prepare the high level logical model or entity level logical model, cross check with your business user or maybe business analyst whether things are as it is required or there is some changes as per the new business policy or rules. And once it is done, then you go at the attribute level because already you got the table with columns. So you have attributes. And then you start working, applying the data modeling rule, whether all these columns are properly distributed, or it may be possible that the person who has designed earlier, he has done a lot of denormalization. And you find that, okay, now it will not work. So we have to split the table into multiple tables. So that kind of decision you take when you work at the attribute level. So logical model at the entity level and the logical model at the attribute level. These two diagrams you have to prepare. And once it is done, means it is approved by the user, yes, whatever is there and whatever you have defined, whatever changes are done as per the business rule is perfect, and they sign it off. Then you go to physical model. So physical model, generally changes will not be much from logical model. But as I said, like as per the business policy or rule, if the changes are done in the logical model from the existing model, then those changes you will come to physical model. But generally, physical model is very similar to logical model. The only difference comes in logical model, we define the things at a very logical level, means in a simple English language. Like suppose you have a customer name. So you will write their customer space name, means just like an English sentence. But when it comes to physical model, you have to follow the database related rules. Suppose if your database is Oracle and Oracle says you cannot have a name up to 30, more than 30 characters, column name or table name. So then you'll find out okay, some of the attributes or entity name you define in logical model is more than 30 characters. So physical model you cannot. So you have to introduce some shortcut, some maybe like a bifurcation between two words like customer underscore name. So those are database related constant you have to follow when you transform logical to physical model. So generally, when we prepare the logical model, we try to prepare in such way that it is very similar to physical model. Earlier, like what I used to do is, suppose if there is a many-to-many relation between two entities, suppose customer and payment relation is many-to-many. So earlier we used to show customer and payment, and then we say, okay, this is a many-to-many relation. But nowadays, people since are working in the computer and they are familiar with these things, even the business users know a lot of things about computer related, database related. So what we do is we define this many-to-many relation within the logical model using the modeling approach. Like we introduce one more entity, customer payment, and then so it is like customer is one entity, payment is another entity, and third entity we show customer payment. So we tell the user, see, this is because of many-to-many relation. So they understand. So nowadays it is not like okay, you prepare logical model in one way, and then when you come to physical model again, you have to do a lot of work. So we try to make the logical model in very similar to physical model because difference from logical to physical is only database related constant. That's all. So to reduce our work, it is a good practice that when you build the logical model, you build a logical model as per the business rule and database constant, so that when you transform it to physical model, you don't have to make much changes. So that becomes much easier. But conceptual model, when you are working as a data modeler come business analyst, and you have to understand the requirement from the business user, conceptual model is must. You should prepare. And conceptual model should not use any technical term because business users might not be very familiar with the business database terms or technical terms. So conceptual model does not include any technical terms either from computer or database. Logical model, as I said that logical model includes both. It will include your business terms as well as include the technical term, but still it should be very simple for the business user because ultimately logical model, you have to sit with the business people or business user or business analyst to make sure that whatever is your thoughts, whatever is your understanding, you are able to convey them. So it should be their language. So it is like a simple English language, business language. And then physical model is purely for your technical team, means your development, testing, all those things. So physical model does not include anything logical or conceptual. It is pure database term, means table, column, relation, constant, whatever database terms are there, everything you include in physical model. And once your physical model is ready, then last stage is convert this physical model into database language. If suppose you are using SQL, then SQL codes will be generated. Or if you are using any other database system, then whatever database language is there, in that language it should be transformed. So that you just give this code to your database guy, he will create the table structure. Because earlier it was like data modeler himself used to create the database table structure, everything. But nowadays, because of security and data governance policy, data modeler nowadays generally are not given access to database. So it is like you prepare the model, transform into code. They will give you some dummy database, transform the code, and then that code will go to the database guy, either DB or maybe like database, a separate person will be there. So he is going to run those script against database to generate the physical tables.
Rahim
Oh,
bhai,
yeah.
sorry to butt in. Just please admit Parvez.
Acha.
Sorry for it.
Yeah, also add me from. I joined from laptop, so I will talk from mobile.
Yeah, it's done.
Thanks.
Okay. So we will see that how we build the conceptual model, logical model, and physical model. And this is true for all the three data model, whether you are working with ER model or dimensional model or data world model. These three models are there. As I said, conceptual model is optional. Conceptual model mostly you will go at the when you are working at the OLTP database level, and when you are working at the data warehouse level or data vault level, you will find conceptual model is very rarely used because you are working against a database which is already there. So you don't require much interaction with the business user, because from the database objects point of view, you don't interact much with the business user. But from analysis and reporting point of view, what they require, that is a different thing. But from model point of view, you don't interact much when you are building a data warehouse or data vault, means data lake. So here basically I'm talking about means conceptual model who prepares. So you can see this mostly the conceptual model is prepared by the business analyst. So nowadays you will find most of the time data modeler is expected that okay, he should know the domain and he should interact with the business user directly. So instead of keeping one more business analyst, until the project is very big or domain is very complex, they will not have a business analyst kind of person. So the senior data modeler will be assumed, okay, he will go and interact with the business user, get the requirement or understand the requirement, and then proceed with the modeling. So that is why person who is working as a data analyst or business analyst, basically he should prepare the conceptual model, which in today's time, data modeler sometimes means most of the time, data modeler himself will take up this job. If it is a completely new database design, then you will find a business analyst there. Otherwise, a data modeler will take care of. And this model deals with subject process and their relationship. This subject process and relation, these are the very generic term. Everywhere it will work. So whether you are at the transaction database level or data warehouse level or data model level, these three things you have to keep in mind: subjects, process, and relationship. Subject and process are referred as entities, and relation how they are related. So some of the entities are referred as a subject, some are referred as a process. So if you go in data modeling approach, when it comes to ER model, subject process are referred as entities and then a relation. So that is why name is the ER model, entity relation model. So in ER model, you will find that whatever subjects are there, they are referred as an entity, but they are identified as a master entity. And the process-based entities are referred as a transaction entity. So you will get two types of entities in the ER model: subject-based entities and process-based entities. So they refer as a master table. Now, when you go to technical terms, they say master table, transaction table. So why they are referred as a master table and why they are referred as a transaction table? Because in the real life, if you go for any subject or a process, you will find that a process cannot happen by its own. For every process, there has to be at least one subject, but generally it will be many subjects. So why subject entities are referred as the master entities or master table? Because they are controlling the process. So they are referred as a master. And transactions means whatever things are happening, that is a transaction. So they are referred as a transaction entities. So master entity are master table, transaction entity are transaction table. So this master and transaction, two terms you will very frequently you will use when you are working with ER model. There is one more subject they have defined. They refer as a reference master. So master and a reference master. There is very slight change between master. Master entities are basically those entities which are responsible to initiate the process directly, like customer. Customer is referred as a master entity because customer initiates the process directly, like customer initiate the sales process, customer initiates the payment process, customer is responsible to initiate the return process. So it is basically those activities or transactions which are initiated by subjects directly. We refer them as a master. Reference master is where entities are responsible to initiate the process, but they are not active process. It means they are indirect, or you can say passive process. Like, for example, if you take a customer initiates the sales process, but we want to analyze in which city this sales happens. So it is like so city of what? City of process or city of customer? There are two ways. Means where the process happens, that city, or where the customer belongs, that city. So it is like if you say city of customer, so it is like city is a reference to customer. So it is like a reference master because city is not initiating the process directly. Who is initiating the process? Customer. And customer belongs to a specific city. So it is like indirect way. Or other way, if you see, suppose if I say process happens in maybe like Bangalore. So the question is who initiated the process? So it is the customer. Where he initiated the process? So we said that, okay, in Bangalore. So is it that Bangalore city has directly initiated? Answer is no. So how it is initiated? So they say, okay, it may be because of uh, what do you say, like in retail business, what you say, that unit means retail branch. So branch has initiated. Where is the branch? In particular city. So customer initiated the sales process in a particular branch, or maybe customer initiated the sales process online. So if it is online, then there is no specific city. So only customer city belongs. So that is why there are some master entities which are related to the process but indirectly. It is not directly. So such entities which are indirectly linked with the process are referred as a reference master. That is one way of identifying. So, another way of identifying this reference master is that generally reference master data will be very limited. Means it is very few data will be there. Suppose we are talking about city. So cities will be fixed like, okay, some 100 cities, 200 cities, 1000 cities. Or maybe you are talking about month. So it is like 12 months are there fixed. So if you are keeping a table for month, it is a reference table. If you are keeping the table for days, it is a reference. Because month and days directly will not initiate the process. That is one way of identifying. Other is these are very limited data, very fixed amount of data. But when you talk about limited data or fixed amount, sometimes it might backfire because it may be possible that some active subjects are there and they are also having very limited data because they are dealing with very limited uh, entity set. So we should not go for this less data or more data. Many people they answer that reference master is basically those table which are having very limited data, very few data. That answer practically is not correct. So it should be like those entities which are directly linked with the process are master, and those which are indirectly linked with the process, they are reference master. So this subject, process, and relation. This is very important. Why subject process when both are entities? Why we need to differentiate subject and process? Because when you are building the database, when you are going to build a transactional database, how you are going to start your process of studying the things or building the database? So there has to be something. Some people say, okay, I will go for module wise. I will take one module, I will take second module, then third module, and then I start building. So the question is how you decide the module, on what basis? So they say that, okay, no, I will see that business organizations, like they have been divided into 4 or 5 different groups or maybe different category. So again, question comes how they have decided, how they have defined. So they say, let's say they have a sales department, they have a finance department, they have a HR department. So there comes your subject and process. If you see, when you're talking about sales, it is a process. When you're talking of payment or accounting and payment, it is a process. We are talking about human resourcing, it is a process. So most of the time you'll find that whenever any business starts any operation, means their business activity, they basically bifurcate their business into different process. So it is like process what they are defining. So same approach we follow when we are going to build our database system. So what we do is we cannot build entire database at a time. So we take process, we divide them process wise. So a process may be group process, which is having so many multiple sub process. So depending upon the complexity, you decide whether you will start with the group process or you want to start with the lower level process. So if you suppose the small organizations are there, you know that, okay, just go at the group process level. No need to go small, means lower level, because it will be very small, just one or two table. So we take the group level. But when we talk about multinational companies or big international companies, we know that one group process may involve so many sub process, and each sub process again will be having so many different layer of sub process. So it may be possible that we break those into different sub process level and pick up one process. So here thing is you are working at the process level. So in OLTP system or in ER modeling, concept is very clear. Go process wise. So that is take one process and then identify for this process what are the subjects which are required. Some may be direct, some may be indirect. And then you identify how these process and subjects are related. So process which are related to subject directly, we link them. And the subjects which are related to other subjects indirectly, we relate subject to subject. So it is like a reference subject will be linked with the subject. But when we come to dimensional model says that all the entities, all the subjects should be linked with the process directly. That means if I have a sales process related to customer and customer is related to city. So in ER model, you have a city related to customer, customer related to sales. But when we go to dimensional model, what we say? Keep the sales process in the middle, relate the customer with the sales, and also relate the city with the sales directly. And if suppose we have to find out how the customer has relation with the city, we say that sales process is there. Through that, you navigate to city and you relate. So this is one basic difference between OLTP and data browse, or you say ER model and dimensional model. So this the day you understand this subject process and their relationship, then modeling becomes very easy. Most of the people, when I ask, okay, what is subject? This is subject is anything like customer, like product. So they start giving example. Don't give example. Define what is a subject. And subject is anything which initiates the process. So anything. We are talking about anything. We are not talking about any process. We are not saying that subject is a process, any process. We are saying that subject is a thing. So which initiates the process. So what is the process? It is nothing but activity. But in business, so many activities might be there. So again, the problem comes. How I know what activity I should take or I should not take? So answer will be from business itself. Whatever business activity they want to capture, we have to consider them. Some of the business activity like customers walking in branch, means retail branch. They said, no, I don't record it. I don't want. So maybe in one day, 100 customer came in the branch, but deposit or withdrawal is done only by 10 customers. So what about 90 customers? So that footfall is there. They said, we don't require those details. But nowadays, the people started talking, okay, I want to know how many people are coming in my branch, how many are doing transaction, and how many are going without transaction. So for that, they have another way. They are using camera approach or some other approach. Sometimes they keep the foot mat, which basically records how many foots are coming on that mat. So now they are capturing, but mostly you'll find that, okay, they say that these are the process which I want to detail, means I want to keep the detail. And these are the processes I don't want any. So we are very clear where are the processes for which we have to define. So this subject process and relationship. So this when you are working as an analyst, business analyst, then conceptual model is the tool between you and the business user. And if you don't know this tool and you don't know how to build the conceptual model, how to explain the business people, because at the end of the conceptual model, you have to take the sign off, means your business user has to say that whatever is your understanding, that is perfect. So that sign off, you have to get it. Because if anything changes after that, it will be basically like change request. And that for that business has to pay. If you don't take the sign off, then business people will keep changing the things and then you have to accommodate. So it is like your timeline will keep going without any payment, without extra. means effort payment. So conceptual model is must, but as I said, like when you are designing a new OLTP system, then only it comes into picture. When you are working against existing systems to build a new integrated system, then conceptual model basically we skip. We start working with the logical model. So the subject, process, and relationship. These are the three things we have to keep in mind. Then logical model basically is again, it is prepared. It should be basically prepared by the business analyst, but here data modeler comes into picture. So it is like a data modeler will build a logical model, and data modeler means it is like what is the data modeler's understanding that has to be clarified by business analyst. So if suppose there is a business analyst, then data modeler based on the conceptual model, he will build the data model, logical data model, and then he will interact with the business user to make sure that whatever his understanding is, that understanding is perfect. So mostly he will cross check with the conceptual model, but wherever there is a doubt, he will clarify with the business user. So logical model is basically extension of your conceptual model, because in conceptual model, we define everything as per the business. We don't use any technical term. But when it comes to logical model, we use a data modeling related technical term. So that is why this model basically is more for data modeler rather than business analyst. So again, same thing will be there, but in the conceptual model, you may define that the customer and sales has many to many relations. So you might draw only one link between customer and sales, and by text you write many to many relations. But when it comes to logical model, then you'll define in proper way. Between these two entities, you will introduce one more entity which will show this third entity is added because of many to many relation. Why it is? Because your database system, underlying database system, does not support many to many relation at the physical level. So that kind of changes you will keep there. And properly, you will use the proper diagrams, you will use the proper notations to define. So it is more pictorial, but you will use the modeling related notations instead of using business related. And as I said, like purpose of this model is to make sure that whatever entities you get, whatever uh, relationship you have defined, whatever business rules. Now here you define the business rule in proper way. So suppose if somebody says that in my case, a customer name must have a two words. So it should be defined at the customer level that name will have minimum two words. It cannot like I was in Saudi for 6 months. I was stuck because my name Abdul Rahim. Okay. In Saudi, they don't treat Abdul space Rahim, means they don't treat Abdul and Rahim as a two different words. They have their own rule. So wherever I go, like I went for banks and payment transfer everywhere, they keep Abdul Rahim as a single word. So that is one problem. Second problem was if you don't have at least two words, then they don't process. For 4 months, I struggled everywhere. They say, no, what is your second name? So I say, my second name is Rahim. Say, no. Abdul Rahim is one word. So 4 months, I was not able to transfer money from any of those money transferring agencies. So I used to transfer by Tariq or by other person. So I asked, what is the problem? They say Abdul Rahim is a single word. I said, no. In India, Abdul is one word, Rahim is second word. They said, no. Here it is one. After 4 months, I think they changed in their system, and I saw that they made Abdul space Rahim. But for 4 months, they did not allow me. So this is referred as a business rule. So you have to define these business rules in a very proper way when you prepare the logical model. So that will be at attribute level. So just so this business. So it is like objects are there, means entities are there, relations are there, attributes are there, and business rules. These four things we define properly in logical data model. But again, logical data model is not very technical like your database. It is basically in between, because you are going to interact with the business analyst or business user, again to make sure that whatever you understand as a data modeler is correct. And then physical model is a pure means technical things. So basically Physical model you prepare considering your database system, not a specific database. So suppose if your database system is relational, then your physical model is as per the relational database system. Or if you are using object database, then you have to build your physical data model as per the object database system. So as we know that right now we are using relational models mostly in our database system, whether you say Oracle or DB2 or now we are talking about Snowflake. So all these are basically they are following a relational approach. So there is no second thought until you go file system. In file system also, ultimately we define same approach. We define multiple files instead of table. We define relation. Now we know that in the file level we cannot define the relation directly. So through common columns between two files we define the relation. So it is like relation is basically through application rather than at the database level. But when you go to the database system, then relation is at the database level itself. So if application fail also, your database system basically will make sure that whatever relation you define, data comes as per the relation. So this basically is a physical model as per your underlying database system, not the database specific like Oracle. Once your physical model is ready, then when you convert this physical model into physical code, then your specific database system comes. For example, if it is Oracle, then you have to transform your physical data model into a script, database script as per Oracle. Now this script will be as per the specific database product. So if it is Oracle, then Oracle has its own data types and constants definition. So your data model should be converted as per the Oracle script. Or if you are using a Microsoft SQL Server, then SQL Server script. So there you may find that, okay, whatever script you generate for Oracle, it will not work on the SQL Server. But physical model is common. So it is physical model is not at the product level. So most of the modeling tool, when you are with the modeling tool, then modeling tool itself will take care of this part. Means transforming from physical model to database script will be taken care by the tool itself. It is just matter of a few seconds or minutes, depends upon the size. So manually we don't transform physical model into your database script. But suppose if you are not using a data modeling tool and you are suppose people are using Excel and all those, then in that case you have to build your script manually. That is the reason why we use the tool, because a good amount of time is saved by the tool when it comes to physical model to SQL. So because if suppose there are 500 tables are there and if you have to write SQL code for creating those tables, defining their constant, it might take you for 2 weeks or 3 weeks time. But with the help of a tool, modeling tool, you can do that job within 5 to 10 minutes. And that will be accurate. Chances of mistakes will be very rare. So this part is where your modeling tool gives you very big advantage. Apart from that, modeling tools help you when you are working at the modeling level, like defining the entities, the relation, all those things. So diagrammatically, you prepare them in a very short time. If you don't use the modeling tool and if you try to use like PPTs or any other presentation tool, it may take time. But when you are using the proper data modeling tool, you'll find the same thing can be done in a very less time. So doing manually as a data modeler, doing manually is not all advisable until it is very small project. If it is a small project, fine, you can do it manually. Means you are dealing with 25, 30, 40, 50 tables, fine. But when it is more than that table, then always it's best to use the tool. If your client does not give you tool, means suppose if they are not ready to buy the tool, that also is not a problem because there are so many modeling tools are available which are free of cost, means open source. You can use those because these tools does not have a very high feature, but whatever we require at the basic level for modeling, all features are there. Some advanced features may not be there, very advanced feature may not be there, but generating this physical model to SQL code, all these will be there. Sometimes what happens, like some of the tools they provide database connectivity, you can generate the code, you can run the code on the database, you can do the reverse engineering. So maybe these features are not there. So that is fine. At least you are getting still flow from top to bottom flow you are getting. So you can use those tools also. So it is not necessary that if the client is not ready to buy the data modeling tool, paid tool, you stuck and you don't use. You can still use like free or open tools, and you can complete the task. Now, when it comes to ER modeling, so basically now we have to start discussing about the ER model. As earlier I said that ER modeling is E stands for entity and R stands for relation. So it is like entity relation data modeling tool, not tool, sorry, data modeling approach. So here the major emphasis is on the understanding of entities and the relation. This is the core part. So already as we have discussed that entities are nothing but anything in the business, not only business, whatever, whether it is a business or non-business things are there. If you're designing database for any non-business entity also, we refer them as a business. So whatever things are there in the business which are basically either subject based or process based, we consider them as an entity. Here the thing is sometimes we find it very tough to understand, okay, how to define entities. So there is a simple way. Simple way is based on the English grammar. So if you know the very basics of English grammar, then understanding this ER data model or entity relation becomes very easy. Entities, as I said, that entities are master entities or transaction. It means subject or process. In grammar term, you can refer them as entities are noun or verb. So whatever nouns are there, they are entities subject based. Whatever verb are there, they are entities process based. So only one exception is there. In the noun, there is one proper noun. Proper noun should not be considered as an entity because proper noun becomes entity instance. For example, when you say Bangalore, Bangalore is a proper noun because Bangalore is a city, name of the city. So, and city is a common noun. So, if you take city as an entity, Bangalore will be one of the record within the city. So that is referred as the entity instance. So except the proper noun, all other nouns will be your entities and they will be master entities. It may be master or it may be reference master. The later we'll discuss, but they are master entities. And whatever is the verb is nothing but process or you say transaction. So it is very, whenever you have a doubt whether it is a subject or it is the process, if you know the grammar, just to check whether this particular word which is confusing you, is it noun or it is a verb? If it is a noun, it is a subject. And if it is a verb, then it is a process. So this becomes much easier when you understand with the help of grammar. So simple, what I do is when I sit with the business people or business analyst, if they talk about, okay, these things are there, so they will basically talk about attribute level, like they say, I need a customer name, I need a customer address, I need a customer uh, phone numbers or mobile number. So I just note down those words, customer name, customer. So then what I do is from those words, I identify what is the noun, what are the nouns and what are the verbs. So suppose say customer name, customer is a noun, customer address, customer is a noun, address also is a noun. So I take customer address both as a subject. Then they say, okay, there is a customer phone number. So customer already is noun, phone number. Number is an adjective, but phone also is a noun. So I take phone also as an entity. So I just identify all possible entities. I don't filter. Just if it is a phone is there, I'll take it as a noun. And then I say, okay, these are the entities. Customer is one entity. Address is another entity. Phone is third entity. And then I check the relation. So one customer, how many address? So business people say a customer might have multiple address, but how many addresses you want to keep in your system? So they say, okay, we want to keep two, permanent or temporary. So they have a business rule that, okay, one customer will have at least two address. So I got idea, okay, it is one too many. So one customer, many address, whether it is two or three or four, later will take one. Then I do the reverse process. Okay, one address, how many customer? Is it possible that in your business, you allow multiple customers to use the same address? So they say yes. It may be possible that from the same family, same home, 4 or 5 persons open account here. So it is possible. So we get idea, okay, one customer, many address, and one address, many customers. So it is many to many. Then I check the same thing, okay, What about the phone number? Do you relate phone number with the address, or do you relate phone number with the customer? So they say customer. Then again, same question. One customer, how many phone numbers? So they say we'll keep at least 2, 3. So it is one too many. Reverse side, is it possible that one phone number you allow multiple customer? So they say, yeah, it is possible. If it is suppose landline number, then quite possible that same house, 4 members are using the same number. So again, it is many to many. So then we cross check, okay, do you want any kind of relation between address and phone number? So earlier it was very common. When it was only landline, there was no mobile. So phone basically was a relation with the address. But nowadays, because of mobile, this phone and address relation is gone. Now we relate phone with the customer directly. So these kind of things we have to identify. So here we find customer is a master entity, address is a master entity, phone also is a master entity. So still there is no transaction. But when we go through other attributes, we'll find that transaction entities also will come into picture. So this is the way how I work. Means whenever I have a doubt whether this particular word is a noun or verb, I just open the dictionary for that word and see, is it a noun or verb? And then if suppose a dictionary says it is verb, but I think no, in the business they are using it as a noun, then I will go and cross check with the business user how you are using this. Is this, are you using as for any activity, or you are using it just only for the reference? So if they say no, it is a activity related and there are so many details for this activity, then I take it as a process. If you say no, it is only for reference, then I take it as a master. So it is very easy to understand when we are talking like entities, or all the nouns are entities, all the verb are process. But when you go in real, you will find that there are some words which are used as a noun and also used as a verb, or vice versa. So those are the area where we get stuck, and there we have to be very careful. So it is not just you know the rules and you start working and define, because when you go in the real environment with the business people, you find that there are some entities, means 90% will be very clear, but 10% always will be there, which will be having some confusion. So that you have to get the clarity with the help of your business user, means business analyst. If not, then business user directly. So this ER, entity and relation, these are the two core concept of ER modeling, and that is why the name is given as a ER data modeling. So E stands for entity and R for relation. Now the question here is, as earlier I said, how do I start? So here approach is you start with the process. Means first you identify a process, and then you identify for this process what is the subject you require. Why we are following this approach? Because a subject will have so many attributes. For example, customer. If you start thinking about customer attributes, you will find that 200 attributes will be there for customer, or even more. So if you start thinking in the direction of customer and the attributes, you might end up 200 attributes for customer. But actually this business requires only 10 attributes. So what business says that identify the process. What is my process? What are the details I require for the process? So suppose if there is a sales process, and this business says that for the sales process, I require only these 10 details. Means it is like a sales number, sales days, sales type, sales quantity, sales item name. So he lists out these are the 10 attributes for the sales process. And then this sales is initiated by customer. So fine. What are the details you require for customer? So he might say that, okay, just I need a customer name and phone number, nothing else. Not even address also. Because if you see how we do the transaction in the supermarket, when you go to any shop or supermarket, you purchase some products, you go for billing. So nowadays you see this, you go Reliance Smart, they always ask your phone number, mobile number, nothing else. They don't ask your name and all those things. Because name and all those already they have fed it through other process. Like they give you one form and they say that you fill up this form, you will get 10% extra discount. So for that, you fill the form. So they already got the phone number and your some personal detail. But I imagine that okay, every day you go for a supermarket and every time they generate the bill and they ask your name and your address, you will never provide. So nowadays, because of personal details, secrecy or rules, it is not advisable to give those details to everybody or anybody. So what they do is they suggest give the phone number. So from transaction point of view, what customers requires, they say that just customer name and phone number is enough. But we don't design a table only for these two attributes. We say that, okay, what are the other attributes you might want to keep for customer? So they said, okay, apart from these two, these are the 10 more attributes we would like to have, but maybe we get or we don't get. So when we design the customer table, what we do is we keep those 10 attributes also, but we make it optional. Means it is not compulsory. Two will be compulsory, name and phone number, but the rest will be optional. So it is not like you design your database tables or database file structure exactly as per the current requirement or current process. You have to discuss with the people and find out what are the things which might be coming in the future or might be useful or required in the future. Keep provision for them also, but make it optional. So, but it may be possible that a customer may have 200 attributes when you interact with the different. So you cannot just take one single approach. Okay, in previous project I worked with customer and there were 200 attributes. Now this new project has come, again customer table is there, let me add 200 attributes. It doesn't work in that way. As per the business requirement or feasibility of the attributes they can or they will have, you have to decide what attributes should be there or should be removed. The same thing happens for the relation also. So sometimes business people are very particular that no, I'm not going to allow a customer to make multiple payment for one bill. One bill, only one payment. So if that is the case, then you'll say, okay, fine, one customer, one payment. But one customer can make multiple bill payment, yes. So it is like one to one from bill to customer side, but one to many from customer to bill side. So in one business, you will find it is one to many relation. But when you go to other business, you'll find that, okay, there is many to many relation. And that is the reason why you see these ERP products are there for last at least 20, 25 years I'm seeing. But still, they are not able to capture most of the, or except the very big organization. Reason is, if they try to define all these possibilities, means maximum possibilities, their database size becomes very huge. Means it is like, if you take Oracle Financial, they say 3,000 tables. You say Oracle HR, 2,000 tables. Now for a small or mid-sized company, entire database gets over within the 300 tables. So why they will go for 3,000 or 2,000 tables? And why they pay for such a big system? So that is the reason for every project we need a new data model, new database design. It may be similar to previous one, but 90% may be similar, but still we do again from scratch. Because we cannot use the same yardstick for same kind of business. Means it is like one database for all banking. It will not work. And as we know that ER model is the best suited for OLTP system. Earlier people, they use it for data warehouse also, but it failed because as we discussed, hierarchy is very high. Number of tables among the hierarchies are high. So in the data warehouse, it does not work where you are dealing with 20, 30 years data. So number of tables, if increases, query takes time, processing takes time. So that becomes a challenge. So this ER model we used only for OLTP system. So if you are working on the OLTP system and you are responsible to do the modeling for OLTP system, then this is the model you have to follow. But suppose if you are purely at the means data warehousing side, analysis side, or analytics side, then you are not going to design anything on OLTP side. So that is fine. But still, when you are going to study the OLTP databases, you require this knowledge, means ER model. So that is why people who are working on the data warehousing project, if they say that I don't know ER model, then they are in a big problem. They go at database level, they see the table structure, see the relation. But when it comes to make the diagram, it becomes tough because they find why there is this third table is there, means customer is there, payment is there, why this third customer payment is there. Because if they have not studied ER model, they will not understand that many to many relation cannot be handled by database system. So that is why ER model introduced third table. So these kind of small things are there which you will understand. Then people, they ask, one NF, two NF, three NF, first normal form, second, third normal form. So I've seen many people, they talk about our database is as per third normal form. So when I ask, when you say third normal form, what is the third normal form? What you do in the third normal form? Have you done second normal form and first normal form? Because these normal forms are defined in such way that they are sequential. You cannot say that, okay, I have done third normal form, but I have not done second and first. It is not possible, because what second normal form rule says that database should be as per first normal form and then apply this rule. When you go to third, it says database should be as per the second normal form and then apply this additional rule. So many people, they talk about the 3NF theorem, but they don't know 2NF, what is the 1NF. So it is a sequential. You have to understand 1, 2, 3, 4, and 5. Like fifth NF, what is the fifth NF? Why we don't say database goes up to fifth NF or fourth NF? It goes, but mostly ERP databases they go up to fifth and then they denormalize. So there is no database which is 100% normalized. There is no, even third NF database also are not 100% normalized. So until you know the normalization, you will not understand the denormalization. Means it is like you follow the rule and then you try to don't follow some of the rules. Means it is like, I don't know traffic rule. Means what is the meaning of red signal, green signal, yellow signal? I don't know. If you don't know, then how you follow? So it is like a red signal is there and you cross. Then other side, police inspector will, traffic police will capture you and say, why you cross this road? He says, the road was empty, I crossed. He says the signal was red. Then you ask, what is the signal? Then he says, okay, you don't know the rule also, traffic rule, and you are driving the vehicle on the road. Okay, give this much fine. So first you follow the rule. So you know the rule, okay, red signal means stop. After that, you'll find, okay, nobody is there, okay, let me cross. But again, you have to be careful. There is a camera, then you should not, because you will be fined. So if you want to go against the rule, you have to take a lot of precaution. Same thing happens in data model. If you have designed a table as per the third normal form, and you find now, because of this third normal form, the table has become 5 tables. Now I don't want to go for more than 2 tables. So you have to merge 5 table into 2 table. So it means you have to do something against the third normal form rule. Now you have to denormalize. So there are rules for denormalization also, how you merge it. And if you are going to merge it, what is going to be negative impact in future, where your database is going to face the problem, that you have to basically note it down. So it is like when you prepare your data model, means document. So in the document, you mentioned that this table is denormalized. If it is denormalized, where will be the impact? So you'll say that, okay, this table, customer and address, is merged together. And in this customer table, I'm keeping a provision for 2 address. So it means you are saying that if it is more than 2 address, your customer, means your data model or database, will not be able to support until you add one more column for address. So like address 1, address 2, and then somebody has to come and add one more column in future, address 3. So you are saying that it is not possible that you expand the relation and you can keep on adding address. Your system will not. If you want that, okay, no, I should be able to add multiple address for one customer without any restriction, then you have to maintain 2 different tables. So these are the things, this is the way how you are going to normalize. So first you know the rules of the normalization, and then you have to denormalize. But before you denormalize, you have to see what will be the impact. And if the impact is very, means risky, then we talk to business, say that, see, I will make 2 address in the customer column, but in future, if you want to go for 3 or more, this database will not support. Somebody has to come and change at the database level, add the column, then you go and add in your application, then only you can use. So if customer says yes, yes, it is fine, because I don't see in next 5 years I will require 2 or more address, more than 2, then it is fine. So normalization and denormalization, these are the 2 things which we have to follow. Yeah, any questions or any doubts till this point?
Abdul sir, it's Varun here. So I was listening to the conversation. आपने एक point mention किया है why we are creating data lake is basically we want to keep history of transactional database into some layer.
Yes.
And we started with the ERP system, and even I have a same thought process like they come up with something called SAP HANA where they are keeping OLTP and OLAP, and then they it's failed or might be somewhere they are using it and they come up with data lake. And in data lake, we are not doing any update, delete, something like that. So
Yes.
here is my question see, I have seen in many practical scenario what they're doing, they are refreshing or they are uploading data into data lake every 4 hours, and they
No,
are
no, no. When you say they are loading the data, is it like truncate load?
they are not doing truncate load. So what they're doing, first time they are doing a full load. Suppose if I'm doing
That is
for
fine.
10 years,
Yes.
and after that, whenever change happen, like CDC, that data only they are bringing and syncing up. Suppose in a day, I have opened an account. Like I went to bank, I made a transaction of suppose 400 rupees. I withdraw
Yes.
400 rupees. After 2 hours again, I withdraw 400 rupees. And after 4 hours again, I withdraw 400 rupees. And I have 1500 balance. And same thing I'm maintaining in my data lake. So I need to maintain this in my data lake also. I might be giving a wrong example because in OLTP they are doing same thing, but I have seen a scenario immediately. They are updating in data lake also. So please correct me because I have seen this kind of scenario where they are updating in data lake as well.
So there are two things. In your example, there are two things. You said 3 deposits are done, correct?
Correct.
So in data lake, you will have one table where they will maintaining the deposit. So deposit details will be there, means date, time, everything will be there, correct? And one more table will be there where they will be maintaining account-wise balance, which is your summary table. It is not your transaction table. It is summary table. This
So
summary
in
table, yeah, this summary table is optional. Okay.
Okay.
See, why the summary table is introduced is suppose they are trying to access the data from data lake for reporting purpose or other end users directly, then they might keep adding some summary table because it will be fast. Correct. So if suppose they want to know on this particular day, what was the account balance of this customer, means this account number. So there are two ways. One way is whatever transaction is done till that particular date, you take sum of all the deposits, sum of all the withdrawals, subtract, and then get it. It might take 30 seconds. But suppose if you have a summary table where you are maintaining it after each transaction or maybe after each day, what is the balance? Correct. So in that you will get account-wise or date-wise balance. So it is like if I want to know at the end of the day on 10th January 2020, what was the balance of this customer account? I just go to that table and pick it up. So that is a summary table. If they are maintaining the summary table, then it update is compulsory. That is why when you are designing a table, you have to be very sure, is it your transaction table, means detail table or summary? If it is a detail table, then in detail table, you cannot go and update. That is not, because transactions cannot be changed. Even in a real business scenario also, no transaction can be changed. If anything is gone wrong also, they have to do the contra entry, means reverse entry. So it is like to nullify. Suppose I did by mistake 3000 deposit transaction, which was mistake. So what I will do is I will go and do a dummy transaction of 3000 withdrawal. So it becomes like nullified. So 3000 becomes 0 plus and minus. And then I will make the actual proper transaction, which was basically 300. So I will create one more transaction for 300. So summary tables are introduced only to speed up your other process which are accessing the data. So don't consider summary tables as your proper table. Summary tables always can be removed because your proper tables are already there. Transaction tables or detail tables are already there. And you can always calculate from there. That is why this means when it comes to summary table, when it comes to ER data modeling, means OLTP database, you will not find the summary data very frequent. Summary data might be very occasional. Means it is advisable that keep your summary data in OLTP system less than 5%. Don't keep more than that. Only the most important or most required data like account balance, that is one column which you will find in OLTP database. But you should not keep unnecessary summary table, because for each transaction, suppose I'm keeping 5 different kind of summary. Whenever any transaction happens, I need to update those 5 summary. So it is like additional 5 process, means 1 real process and then 5 internal process. So, and when you are doing 5 internal process, means sometimes resources are going to be busy, so it will impact the performance. So that is why you have to be careful. So it may be possible that people who have designed the or data lake, in your case, your example, maybe they designed this summary table to give the performance to reporting. So if they are doing the reporting, but if it is not reporting purpose, and if it is just populating the data warehouse with summary table, then if I'm there, I will not keep this summary table. I will keep my detail table and tell the ETL people, you summarize and keep it. If you want day-wise summary, keep it. Means take the detailed data, every transaction, sum it up, and you, because you can summarize at the hour level, you can summarize at the 4-hour level, you can summarize at the day level. But if I'm keeping a summary table at the day level, then ETL developer think that, okay, there is only day summary, so what to do? Why should I take other summary? So they will keep only day summary in the data warehouse. So OLT means data lake generally should not have a summary table until there is some trade-off, means some of the reports they are generating from the data lake directly. So some people, like in my this current project also, they are doing the same thing. So I said that, why you want to disturb your data lake? Why don't you create another simple database, one small database, keep all your summaries there. Don't mix up with the data lake. Let the data lake be proper data lake. Whatever summary additionally require, create one more schema. Same database, just create one more schema. Keep the summary table there. Because ultimately these summary tables are not part of your data lake directly. They are indirect. So keep them in separate schema, so that people, when they are coming to access your data lake, they have very clear vision that, okay, this is one data lake which all tables are detail level, proper one. And there is another extension of data lake schema where we keep all this summary data, aggregate data, all those. So segregate it at the schema level. Don't mix with the original data lake table.
रहीम सर, आजकल ना क्या चल रहा है, लेक हाउस आर्किटेक्चर चल रहा है या मडीलियन आर्किटेक्चर चल रहा है. तो उसमें क्या करते हैं लोग, क्या करते हैं, जैसे हम डेटा लेक आर्किटेक्चर की बात करते हैं तो लोग क्या करते हैं, डेटा लेक भी रखते हैं, डेटा वेयर हाउस भी रखते हैं. तो उस केस में क्या होता है, आपको कंसिस्टेंसी दोनों जगह बनाना पड़ता है, डेटा डुप्लीकेट करना पड़ता है. यहाँ पर भी आप रखोगे डेटा, यहाँ पे आप समरी रखोगे. आजकल क्या कर रहे हैं, डेटा ब्रिक्स में या स्नोफ्लेक में दे केम अप विद द कॉन्सेप्ट ऑफ लेक हाउस आर्किटेक्चर. तो उसमें क्या करते हैं, विद हेल्प ऑफ डेल्टा टेबल्स और डेल्टा लाइफ टेबल और आइसबर्ग टेबल और हुडी टेबल्स रखते हैं. और उसमें ही आपका जो ये हिस्ट्री होती है या अपडेट होते हैं, उसको डेटा लेक लेवल पे ही कर देते हैं, इवन इन S3 और अज्यूर ब्लॉब स्टोरेज. तो ये भी करते हैं. तो उस पॉइंट ऑफ व्यू से भी मैं थोड़ा जानना चाह रहा था, लाइक व्हाट इज द बेस्ट प्रैक्टिस और व्हाट वी शुड फॉलो.
See, whatever terms they use, so they are saying a lake house, correct?
हाँ जी, हाँ जी.
Now, if I keep my lake different and my keep house different, what will be the problem?
प्रॉब्लम आता है एक्स्ट्रा कॉस्ट, और प्रॉब्लम आता है कंसिस्टेंसी और डेटा डुप्लीकेशन. और एक्स्ट्रा आपको एक और लेयर मेंटेन करना है फॉर वेयर हाउस. तो आप लेक भी मेंटेन कर रहे हो, वेयर हाउस भी मेंटेन कर रहे हो, आप डबल वहां पे दे रहे हो, डबल ETL प्रोसेसिंग हो रहा है. तो आपका जो ये होता है, कॉम्प्लेक्सिटी बढ़ जाता है. तो that's why people are moving away from data lake and slowly they are going into lake house architecture.
No, complexity बढ़ता नहीं. Complexity आपका इस lake house में will become more complex. Why it becomes more complex? Because when you say lake house, see, ultimately data is at the database level in the form of tables, correct?
Correct.
So suppose if I keep my data lake separate and data warehouse separate, so it may be possible that in data lake I have 300 tables and data warehouse I have 100 tables. Okay.
Okay.
Now, if you merge both, will there be 400 tables or it will be less?
It will be, I can say, It will be more only.
So number of tables will be nearly more, same or more, correct? Or
Yes.
so if you see from number of tables point of view, you already are same. So when you say that ETL process will be reduced, ETL process not reduced because you are still dealing with same 400 tables, correct?
Okay.
So it is not like you are going to, like some people they say that okay, what I will do is in the single ETL process I will load the data for 3-4 tables, which is not advisable. Because if suppose there is any change in any of the 3 tables and you have to open the ETL program which is dealing with 3 tables and you are making changes for 1 table. So again, the testing has to be done for all the 3 tables. So whatever you think today, because of reducing the number of application or number of tables, it becomes very like a small, it becomes less. Practically, in long term, it becomes very complicated and it takes more time. And this has been proven because for last at least I am seeing 30 years, whenever we try to reduce the number of tables by merging them unnecessary into single table, just after 2 or 3 or 5 years, same business they struggle. So that is why when you go back in the past and you see like last 15-20 years, you will find that whenever they try to combine the things together, they try to merge the things together just to reduce the number. Reducing number is not an answer. It is not an answer that okay, things will be becomes much easier. It becomes more complex. It becomes more complicated. And one thing what we need to understand is, that is why I said, for whom you are designing things. If suppose it is a small company, it is a mid-sized company, people say that your requirements are very limited. Why you want to go for flexible? The question is, today that company, like you see this Paytm, they started the Paytm 10 years back. They were very small. For 5, 7, 8 years, they were nothing. Suddenly in 2020 COVID time, they became very big. And now you see this, the size. And the way they are expanding, the way they are providing the feature, they need a lot of flexibility, not only in the application, but at the data level. So if suppose something has been designed in a very restrictive way, very integrated way, complex way, which looks as simple because the numbers are reduced, in future it becomes a problem. So if you see this, people who are like Snowflake is talking about, you use so many technical terms like it is, what you said, can you repeat again? I will give you answer.
जैसे देखिए मेन डेटा ब्रिक्स में अभी डेल्टा टेबल का कंसेप्ट चल रहा है और वो
That
आया
is very
है
old. Delta tables are very old concept. Okay. Yeah.
और
Go ahead.
आइसबर्ग AWS में आइसबर्ग आया है
What is
Hadoop में
iceberg? I have not heard about iceberg.
is
Can you?
similar to डेल्टा लेक ओनली आप डेल्टा टेबल ही बोल सकते हो AWS में आइसबर्ग है
Okay.
इट्स अ फाइल फॉर्मेट हडूप में हुडी लेके आए हैं वो इट्स आल्सो फाइल फॉर्मेट स्नोफ्लेक में भी एक सिमिलर होता है जो अपडेट करने देता है उसका नाम मेरे दिमाग से निकल रहा है इट्स सिमिलर टू योर डेल्टा टेबल तो जनरली आजकल क्या कर रहे हैं इवन इन माय प्रोजेक्ट और प्रीवियस प्रोजेक्ट पीपल प्रिफरिंग in data lake also they are doing a update so this is my that's why I asked this question purposefully कि वो सही है नहीं है क्यों कर रहे हैं what is the reason so but I got an answer
See, it depends upon the person who is modeling. If I'm there, what I
Yeah.
will say, I will keep summary table as a part of data lake, but I will say it is an extended data lake. So
Okay.
whatever is my core data lake, that database I will keep very simple.
Okay.
And whatever summary tables I require, whatever like off the track of the means track tables I require, means which is not part of my core data lake, I will keep them in separate schema. I will say them this is data lake, but what I will say, I will keep 2 separate schema. Correct. Now I give you example, simple example, real life example. We used to have a house like 25-30 years back where there used to be this bathroom and toilet separate. It used to be like mostly far away from our main rooms, correct? Like kitchen room and room. So it was very far. So what was the advantage? Advantage was that okay, means it was like no bad smell coming to your room, all those, since it is far. Disadvantage was you have to get up and walk at least 10-15 steps and go and use it. Okay. Then when it became like a space requirement became a problem, population started increasing, space requirement became a problem. People did not have a huge area. So what they said, so where to make this bathroom? So they said, okay, within the house, let us have one separate place only for bathroom. So it was like 3 bedroom is there, kitchen is there, and one or two bathroom is there. So people they come out of their room and go to the bathroom. Then space became more restricted, more smaller. So they said what to do. So they said, okay, second thing is bathroom is there. 3 different families are staying. They have to come in front of everyone go. So they started having a attached bathroom. So when it comes to attached bathroom, so physically, if you see how attached bathroom it is that part of your room, there is a wall, correct? There is a door. So it is like you have extended room which you are using as a bathroom. But within the room itself, you are not using the bathroom, correct? So if suppose I have a data lake, I will say that, okay, fine. In the data lake, I want to keep all my other tables, which are extended table, summary table. So what I will do is I will take one more schema, extended schema. So it is like I have a Oracle database or I have a Snowflake database. I will create 2 schema. One schema, pure data lake tables as per the proper rule. Other schema, I will keep this, again, I will say it is a part of data lake, whatever is lake house, whatever you say. And I will keep tables separate. But when we draw the architecture, we say that this is my lake house. In the lake house, we will have data lake tables as well as data rows kind of tables. So in architecture, it looks okay, it is a lake house, but how physically you implement, that is important. Showing is fine, I'm using lake house, one diagram, one box is there, lake house. But when you go to the physical level, make sure that at the physical level, it should not be mixed up. Means it should not be like if I connect to the database schema and I find 300 tables are there, and then I have to search, okay, what are my summary tables? So tomorrow, if I generate my diagram, I find very complex diagram. So what I say at the physical level, how you distribute. So when you're talking about architecture, you define the architecture at the conceptual level or logical level, but how it is done at the physical level, that is also important. So if suppose you say only in one schema, I will keep everything, means it is like I have a room. Nowadays you see this, they refer as a studio. What they do in a studio, your bedroom is there in the single room, your study area is there, your kitchen area is there, your bathroom area is there, everything is in the single room itself, just with some small partition, that's all, not a physical. So that room is good only for one person. But when it is like family, then you cannot have a 3 studio room with like that. So you have to go for a proper structure. So it is like your core area is for these core things, then you have extended area for all those other activities or other things. So that is the way how you define. So these fancy terms are used by whenever a company comes with a product, they have to be different from others. If they use the same terms which is already there with the other company, then who will buy? So we have to be careful when we are going with this. Means core concept is same, just they are using different fancy terms. Then it doesn't make any difference. Only thing what we have to say is if Snowflake says that, okay, I'm giving a good performance, very good performance compared to Oracle or DB2 or IBM. How they are providing that we have to, because this we have seen with Teradata. Teradata also started claiming that why you people are building your data warehouse. I will give with the OLTP itself, your OLTP system, without changing your data model, I will give you performance. So people started moving to Teradata, but later they came to know that, okay, they have so many restrictions. Means you have to use their database system, they have to use their operating system, you have to use their infrastructure also. So gradually you find that Teradata is out of market because they were playing with the words. It was basically same thing, but they were playing. And suddenly they said that, okay, if you want more than this, then you have to invest here, means at the hardware level or software level. So then client says that, okay, if I want to get a performance, you are saying that change the entire thing. Means it is like, I want one more small bathroom in my house. And you are saying that, okay, sell this house and go for a new house. Then it doesn't make any sense. So that is why If you see this, if you want a flexible house, then you cannot go for flat, apartment flat, because you cannot extend. So you have to purchase the land and build a house, maybe one floor. After 10 years, when your family members are increasing, you go for one more floor. So keep on extending, but your initial investment will be very high. If you don't have initial investment, then you have to compromise at the flexibility. You have to purchase apartment house, which will cost you maybe 3 times less than the individual house. But in future, if family members are increasing drastically, then that house will not be enough for you. So you have to go for another house. So what to do with this house? So until you identify with the business user what type of restriction they have. If they say money restriction, then you have to say that you have to compromise at the flexibility level. If they say money is not a problem, time is also not a problem, but I need a very flexible system which can support my process for next 15, 20, 30 years without much changes. It should not be drastic change. Then you have to design the things in very flexible way. Means you have to follow the rules more than going against the rule. So that is a simple way. Means normalized, following the rule, or denormalized, going against the rule. The more you go against the rule, your system will be very restrictive. So nowadays, what is happening is means even clients also come with see, my budget is very limited, timeline is very limited. I need a system to be ready very quickly. So in that case, you cannot go for very flexible. So you cannot define that, okay, this is the thing which I'm going to follow everywhere same way. And these jargons and different terms will keep on coming. What you need to go back is at the jargon level, when they say lake house, just try to understand what is the meaning of lake house. They are saying a data lake and warehouse, both are combined. That is fine. Already we are using for last so many years. So lake is there, house is there. Now they are saying that don't show the lake and after lake house. They are saying that, okay, show the lake and house parallel. Means I have a lake and house. So it is just a presentation, that's all. Ultimately, they are doing the same thing.
Okay, Rahim bhai. And one more question here. Whenever you are telling about data lake, so
Mhm.
my understanding of data lake is we are storing data in files, and generally we prefer to store in a highly compressed format, either Parquet or ORC, based on the requirement, and then we'll create a schema. So please let me know if you have different understanding or anything we need to add here. Please correct me.
No. Data, when we say data lake, see, when we are talking about the data lake, we are talking about the basically database. We are not talking about the storage at this stage. So
Okay.
storage depends, like as I said, if you have a more data which is structured, then I prefer database. But if the more data is which is unstructured, then I will prefer file. Now, if I have both the data, means my data lake has both the data, structured as well as unstructured, then you have to see how you manage. Because if you go everything in file, you will face problem in future. Like you see this. So that is why it has to be hybrid model. See, something will go to your file and something will remain in your database, because database system has its own advantage that you cannot negate. And file system advantage is, as I said, like when it is unstructured, then database is not the option, because database storage and retrieval takes a lot of time compared to the file system. So depending upon the performance requirement and depending upon the security requirement, plus you have to see like what is feasible for a client. Because if you go for database system, then he has to invest more, his cost will be high. With file system, cost will be low, there is no doubt. So you have to distribute. Means you cannot say only one storage will be good for entire database. It is not, it does not work. So you have to distribute, and then accordingly you have to give the architecture.
देखिए मेरे केस में क्या होता है, how I am designing it, I'll see the reporting requirement. If suppose I am having 10 operational reports in VI, then what I'll prefer, like I'm using AWS or Azure, so I'll create a data lake, and most of the data will be in S3 storage or blob storage, because that is cheaper. And whatever is required only for reporting, that only I'll put into database. And generally, in case of AWS, I go with Redshift, and I'll create another ETL pipeline, or I'll put into SQL Server. Only that part. And for most of the machine learning use cases, I'll have another layer which will be, and in data lake, I have multiple layer. Like one is lending area, another one is staging, another one is curated layer. And from curated layer in data lake, it will go to data warehouse. Like in my case, it's a Redshift. So this is how I see a data lake. And in this data lake, all my data, it's a structured data. Whether whatever the pipeline I'm doing, even I'm doing whenever I'm talking about Lakehouse. So Lakehouse, I have say okay, I'll create another layer where I am keeping a summary, or I name it's a curated layer. So there also I'm keeping all my data in form of files. It's a Parquet file, and on top of Parquet file, I'll give a schema, or I'll create a structure. So this is my understanding. So most of my data, and when I'm talking about tables here, I can say it's just a logical layer I'm creating, but underlying data will be in files only.
That is fine. See, how the users are accessing is using through some language, correct? Maybe SQL or something, or no SQL, correct?
SQL, or they will use Spark. Underlying, they will be using PySpark. They will be using this one data frame, or they will be using Spark SQL. तो structure उनको मिल जाता है वहां से.
So that is why, see, there are two things are there. One is your physical storage, other is your access.
Correct.
Now, who is accessing the data? If the access users are business kind of user, they don't know much technicals, you need to provide them data in a very simple structure, correct? So they will be looking for a simple language, simple tool which will connect and get the data.
Correct.
Those people should not be means burdened with this technical jargon. How you store the data, those people, they don't care. What they care is whenever I need data, I should get in the simplest way. So that is one thing we have to keep in mind. Now you are saying that your data is in the file. It doesn't matter, but you are providing the data in a very simple format with simple way. They are able to access, that is okay.
Okay.
So physically, you have to see, like, if my physical storage file is giving me low cost and better performance, go for that. If you think no, cost is low but performance is not good, then you have to see for other alternative. Because for companies and business, cost for a certain period, cost is very important. But when the performance starts going down, then their cost becomes much higher. So you should not give much stress on the cost. You have to talk to the business and say that today your cost may be low, but with the growth, data growth, when your performance gets impacted, your cost will become very high. Because for every report, instead of 3 seconds, you are spending maybe 10, 20, 15 seconds. Will you be ready for that? If they say yes, it doesn't make much difference, then it's fine. But nowadays there are business where they said, no, I can't give you more than 3 seconds. It has to be within 3 seconds or maximum 4. I can't give you 10, 15 seconds. Then, and if this underlying storage is taking more time, then it will not work. So then you have to say that, okay, then I have to think of other way. Like you said, you will create the summary tables. So if it is not online data, means as soon as transaction happens, it should be reported. And if it is suppose delayed, like periodic, 1 hour or 2 hour or 4 hour, then fine, you can build another layer. So this architecture will change as per the client's requirements. So we cannot give us a one solution for. So you have to see the client. What is the emphasis on of the client? Is it like he needs more performance, better performance, or he needs more accuracy? Sorry, accuracy, not accuracy. This flexibility. So these two are more important things. One is the flexibility to adopt in the future without much changes. Other is a performance. Performance, they don't want to compromise nowadays. They want first preference is performance. Second preference, they say, is I need a flexibility of changes to be adopted by the system as quickly as possible without much changes. Third comes there, this cost. So because they can control the cost, they can allocate little bit of more money. if you convince them for performance and flexibility. But if flexibility is compromised for the cost, today's cost, then they should be informed very clearly, like after certain point, you are going to struggle whenever new things are like, some people say, no, I'm going to use this. In one or two cases, I had a dealing. They said, no, I don't see any changes, much changes in the future, next 5 years. So I ask only one question. Is it possible that your business might take over another business in next few years? There is a possibility or not? Then they get a like a bill in their mind. Yes, it is possible. I can take over. My bank can take over. My retail can take over another one. So if you take over another business and that business already has a system, how you integrate? A lot of issues will come. And if your database is very restricted, then integration becomes much more complicated. So complications will come when you integrate two systems into one. But whether it will be more complex or it will be less complex, it depends upon how those two databases are designed, how those two systems are designed. That makes a challenge. So these things we discuss them, but ultimately what client says, according to that, if he is more budget cautious, then we have to compromise. Like, okay, let us keep the things in. And one more thing which I have noticed is like some of our architect, what they do is they change the architecture as per the business users understanding, as per the business users suggestion, which is completely wrong. You listen them, you understand them what they require, and within their restriction, you define your architecture. Architecture, you should not consider a business user's suggestion. If they say no, don't keep this, keep that, they are not the right person. If you listen them, and after 6 months, if anything goes wrong, they will say that you people are expert. You should have suggested that. Okay, this is not correct. This statement I have listened many times. So architecture we have to define whether it is a logical architecture or it is a physical architecture. How we are going to implement it is our as an architect. You have to take care. Don't listen the business user. They don't know, but they will still poke in you because there's something they know about computer, something they know about technology. They read something, they attend some seminar, so they know. So accordingly, they will give. But we should not consider them. Just take their input. As per their input, design your own architecture. So as I said, like they need. Suppose somebody is a business team. That somebody says, "Why don't you come with lake house?" Yes, sir, we will do it. Lake house is there. You do your lake and data warehouse, maybe separate, but show them. See, this is my lake house. This is the data lake. This is my data warehouse. Instead of showing them one after another, you show them. Well, that's all. So how you present that matters, but how it is implemented, make sure that technically you implement in a proper way. So it is mixing the things in a single schema is not advisable. Like even sometimes what happens, suppose if you do, means somebody else designed the architecture, they did in one schema, what they did, they put all the tables, data lake tables and all the warehouse tables in one single database. And they said, this is lakehouse. When I go in such scenario, what I say is, this is going to take a lot of time. Every time when people are going to work on this database, they have to spend time for searching the tables. What are my data lake tables? What are my data warehouse tables? So what I suggest them, let us create two more schema. In one schema, I will keep synonyms, only synonyms for all the data lake tables. In second schema, I will create synonyms only for all the data warehouse tables. And I will tell my users, don't go to this data lake. Go to the schema for data lake. Go to the schema for data warehouse. The actual schema where all the tables are kept, I will not allow to touch because it is going to take time. You are searching so many tables unnecessary. So better you come to the schema where I'm just keeping synonyms. Maybe 300 synonym for those 300 lake tables and then 200 synonym for 200 data warehouse tables. So it makes very clear. People who wants data lake table, they go to schema A, and whatever tables are there, they know all are data lake tables. Other group of people will go to schema 2, where synonyms are created only for data warehouse table. So they don't spend unnecessary time for differentiating whether is this a lake table or it is a warehouse table. So these kind of things we have to do. This is part of your data management. When you're talking about data management, it is not like just data. how you manage the structure, how you distribute the structure, either physically or maybe just logically, just creating the synonyms, creating the views, how you distribute the things.
Okay, Rahim bhai. I got the point. So basically, data lake will keep only transactions,
Yes.
and in data warehouse, summary tables. And how we design it doesn't matter. It's up to us, storage and all those things, whether in database or file. It's up to us based on the requirements.
You have to do some means it is like a POC kind of things. If you have a doubt, which is giving me more performance, better performance, then you do some POC. You take some tables in database, some tables in file, and do POC and see the performance. So that kind of things you can do, and then accordingly you can distribute. Like we know, when it comes to unstructured data, keeping them in database is going to impact the performance. There is no doubt, and also it will be costly because that will be huge amount of data. So keeping those unstructured data, audio, video kind of things in database will require a lot of the space, and then managing them at database level, performance gets impacted. So in that case, file is a better option. But again, it depends on the tool, which tool your end users are using, and how comfortable those tools are while connecting to database or connecting to the files. That also makes impact. So there are so many tools, like every tool has their own limitation, and within those limitations, you have to provide. So until you know the end user tools, it is not like you simply say, okay, this is the way I'm going to store. So sometimes because of the tool also, we have to change our architecture a little bit.
One more thing, Rahim bhai, in which database generally you created data lake if it is a structured data?
See, right now I'm working, it is a Snowflake. Means for this Union Bank of Philippines, it is a Snowflake.
Okay. And
But
what is the underlying storage you are using?
no, Snowflake is having their own storage. So when you are working with RDBMS, in RDBMS they say that we will take care at the file. See, ultimately all the data is in the file, correct? So only thing is your tool is using the file directly, or your tool is interacting with the system, and that system is using the file. So when you come to RDBMS, in RDBMS they say that it is a physical data independence. That means that RDBMS is providing you transparency with physical. So they will maintain file. How they maintain file, it is up to them. That system will take care of, DBA will decide how to distribute the physical. From the tool point of view, user's point of view, RDBMS says that you deal with me with the logical structure like table, view, synonym, sequence, schema. These are logical structure. So they say that you cannot interact with my file directly because they are encrypted file. They are a completely compressed file. So your tool cannot access them. But if suppose you want that, no, my tool should be able to interact with the file directly, then you have to go with the file structure yourself. Ultimately, your physical data is in the file, but only thing is whether those files are maintained by a separate layer, which we refer as a system like RDBMS, relational database system, or it is like file is maintained by your application tool itself. Or maybe if you are using suppose a big data, then you are referring, okay, there are so many other processes are there which are maintaining the file, and your request will go to those processes. They will give you the data, or they will take the storage on behalf of you. So
In
when
your
you say,
case, in Snowflake, you are designing data lake plus you are designing data warehouse separately. There are two different
yeah, two
schema
different,
on
and
your.
both are in the Snowflake only. Means they are keeping the data lake also in the Snowflake. In one schema, there is another schema which is like keeping the data warehouse. So
Got it.
means
Got
today
it.
it is one schema and one database, but in future it will become like they will have two different instances maybe. One instance they will maintain with, because keeping one instance for both the data is risky. If suppose one instance is down, then both the databases are down. So mostly what they do is they create multiple instances. One instance will be maintaining a data lake, other instance will be maintaining data warehouse. So it will be two different database systems.
Got it. I'm good, Rahim bhai. We can proceed.
Okay, I think we'll complete today. We'll continue on Monday. Any other question, any other doubts?
No, Rahim bhai, we are good.
Okay, so we have discussed till this point. So next we will start with this entities and all those. Like practically, we will see how we identify the entity, how we define the relation. Means what are the different way how we can identify the relation, because relation is one thing which is ER model is the most important part. Means is it one-to-one relation, one-to-many relation, or many-to-many relation? When you go for many-to-many relation, number of tables will increase, because for every two entity, you will have to add one entity if you are going for one-to-one. Sorry, many-to-many. If you are going for one-to-one, then it will be two entities will become single entity. So it is like two tables will become one table if it is pure one-to-one relation. If it is one-to-many relation, two entities will remain two tables. If it is many-to-many relation, then two will become three tables. So you can see that one table, two table, or three table. So when you go for more flexibility, number of tables will increase. When you restrict the flexibility, number of tables will reduce. But it depends upon the business rule. Purely depends upon the business rule. It is not like as a data modeler, we take a call. Okay.
Thank you, Rahim bhai.
ठीक है rahim. Thank you.
Okay,
Assalamu alaikum.
thank you. Salam. I will share this recording in the same group.
Cool.